Hello, my dear students. Happy morning to all. I am once again welcome you all back to my channel. You are go to spot for making self and mutual induction concept in a very simplest manner. And today the class is divided into two super cool concepts. One is about a self induction, another one is about mutual inductions from the electromagnetism. See, here you are even sometimes you might have wondered about how transformers works, and even sometimes while switching the circuit, whether it is in on or in off conditions, it creates some sparks, and even sometimes it gets some delay. So well, this is the main secret here is the main secret behind all the concept here is about induction. So we are going to see about a self and mutual induction. We'll see in little detail, and there are some tips which is here which is given, that is our fortunate things that also we are going to see in this cases in this presentations. Welcome you once again. On the session is about self induction. An EMF of 5 volt is produced by a self induction when the current changes at the steady rate of 3 ampere to 5 ampere. Now current changes here is 3 ampere to 5 ampere in 1 millisecond. Then the value of self inductance here is, see this one, changing EMF. See, actually changing EMF I just mentioned here, E is equal to RE1. E is proportional to di by dt. So whenever the current produced over here, the changing current which is directly proportional. From this one, E is equal to L into di by dt, where L is called as self induction. See, from this one, E value they have given, that is 5 volt here. L only we are going to find out, and the current changes, changing current here is 3 ampere to 2 ampere here, and the timing here is 1 millisecond, 1 into 10 power minus 3, that is about the second here. See, from this one, L is equal to 3 minus 2 here is 1, and whole divided by 10 power minus 3. See, from this one, L is equal to, so this is 5 here. In this one, L is equal to 5 into 10 power minus 3 Henry, or 5 millihenry. So self induction or mutual induction can be measured in Henry. So answer in this case, important volt division problem. See, a coil has an inductance. So they have given an inductance value 0.05 Henry, and the turns here is 100 turns. Calculate the flux linked with it when a current of 0.02 ampere is passed through it. Now I just mentioned. Now what I'm going to mention here is, you just consider about a coil of an inductance. See here, so this is about the coil of a self-inductance. You just consider here, they have given L is the self-inductance. The current is passing through the coil here is 0.02 ampere. Now self-inductance they have given the value here is 0.05 Henry, and here the number of turns what they have given here is 100 turns. Now the flux is linked to the coil. See this one, there is whenever the current is flowing through the conductor, here the flux is linked to the coil. Now this one, the flux is directly proportional to the current flowing to the coil. See, from this one, pi is equal to L into I, where L is called as inductance, self-inductance of the coil. Now here is, this is only one coil flux. Suppose if you are having n number of coils, so n number of flux will be equal to L into I. So what they are asking in this case, they are asking flux when a current passing through here is, the flux is linked to the coil. They are asking about the flux. See, from this one, pi is equal to L I divided by N. Now from this one, substitute all the values here. So pi is equal to L value here is 0.05 into current here is 0.02 whole divided by, and what they have given the number of turns here is 100. Now for better understanding, what I mentioned here is, this is 5 divided by 100 is 0.05, 2 divided by 100 is 0.02, and this one here is 1 by 100. So what you are having here is 5 into 2 is 10, 10 into 1 divided by 10 power 6, or else we can mention as 10 into 10 power minus 6 Weber. So that is about flux linked in the coil. So answer in this case 10 power minus 6 is micro, so microweber. So answer here is problem similar like the same previous one, self-induction. A long solenoid has 1,000 turns. When a current of 4 ampere flows through it, the magnetic flux linked with each turn. So for each turn, they have given 4 milliweber, the self-inductance of solenoid. So what they are asking here is self-inductance of the solenoid. See here, they have given, in this case, they have given N value here, that is 1,000 turns, and the current value they have given I 4 ampere. And this one flux linked with each turn, that one they have given as pi. We just mention as pi naught because this is one single turn. So number of turns how you can mention here is pi is equal to n into pi naught. So that is about, that's what we have seen in the previous one. Hope you remember this one. Pi is proportional to I. Again the same, pi is equal to L into I here, and this pi value what we can mention here is, I just mentioned pi is equal to number of turns here is 1,000 into, and pi naught value what they have given here is 4 into 10 power minus 3 Weber. Now from this one what you are having here is 4 Henry, that is about what we are having here is flux linked with the coil. Now this one pi value they have given, what they are asking L value, L is equal to what, that's what they are asking. From this equation now 4 will be equal to L into current here is 4 ampere here. See from this one L is equal to 4 divided by 4. So what you are having here is 1 Henry. That's all. See this one, I'm sorry, this is about flux means this is about Weber. I'm sorry, this one is Weber. So answer here is 1 Henry. So in this case answer here is 1 Henry. Old important old question paper problem. A coil is wound on a rectangular frame, keeping the number of turns per unit length is constant. See, this is the key term. What they have given here is number of turns per unit length is constant. Say for example, what you mean by number of turns per unit length? Say for example, unit length means if you consider 1 meter length of the wire or coil which contains 100 turns. Say for example, now what I'm going to do, this one I just make into 2 meter length of the wire. If I'm extended this one, first 1 meter 100 is there, 100 number of turns, second 1 meter also 100 number of turns. If you consider about the ratio number of turns per unit length, see for this one number of turns here is 100 per unit length 1 meter, what you are getting here is 100. Similarly now the number of turns here is 200 and the length here is 2. So what you are having here is the same 100. So in that case which has been maintained as constant here. So in this case what they have mentioned here is the linear dimension of the coil are doubled. See here linear dimension in this case, hope you remember this one, linear in this case length and breadth. See, you just consider here linear dimension of the coils are doubled, then the coefficient of self induction. Now in that case we just go through some IP part of this one. See here, for in case of a long solenoid in this case a number of turns wound coil with the length. See here I just mentioned like a solenoid, hope you remember this one. See the number of coil which is having a length. See you can mention like this is the length of the coil which is having number of turns over here. This one we call it as a solenoid here. In this case what they have given here is mu naught and mu r are the permeability of relative permeability and permeability of free space. A is about area, L is about length. In this one, this is about the solenoid. Similar concept, this is a coil in a circular shape, the same one which has been wounded in case of rectangular frame. So rectangular frame, so what I'm going to mention here is, so self inductance, coefficient of self induction here is mu naught, mu r here, and n square, length here is a, length is L, area here is a. Now in this one, for the first case, L1 equal to mu naught mu r is not going to change. I just mentioned just like that, mu naught mu r n square, that is number of turns per unit length, also constant here, and area here is, area is going to change. That one we can mention as this is A1 and the length here is L1, right? Similar in this case, L2 is equal to area C, area A1 equal to A, and even length L1 also you can mention as general length L1 initially. Now what they are going to increase? They are going to increase double the amount linearly, so that mu naught and mu r is there, n square, that and all same here. Here area is A2, length here is L2. So L1 by L2, from these two equation common terms, this one will be cancelled in both the cases. So what you are having here is A1 L1 divided by A2 L2 here. See, they are going to increase twice the amount. Area here is A and length here is L. Area, what you can mention here is, area here is you can mention like a length into breadth. Now this one you can mention like a length here is 2 times of length and 2 times of breadth, and even length also increases for 2 times. See, from this one what you can mention here is A into L, and this one length into breadth is again area here, so 8 times of area, and this one L you can mention just like that. From this one this will be cancelled here, so 1 divided by 8. So from L1 by L2 is equal to 1 by 8. So in this case L2 is equal to 8 times of L1. So how many times which has been increased here is 8 times. So answer here is 8. Problem again. Problem is on self-induction. A coil has a self-induction of, they have given self-induction L value 0.01 Henry, and the current through it is allowed to change the rate, that is changing current over a time here is 1 ampere per 10 power minus 2 second. Calculate the EMF. Now here, according to Faraday's law of electromagnetic induction, so the induced EMF in the coil E is equal to, what you are having here is L into di by dt. Now already they have given, see L values what they have given here is 0.01 Henry, and the current here is, changing current here is 1 ampere, and whole divided by timing here is 10 power minus 2. So this one what you can mention here is 1 into 0.01, that is 0.01 into 10 power minus 2 in numerator here is 10 square. So this is 0.01 into 100. So what you are having here is 1. EMF in this case here is 1 volt. So answer here is problem. This is quite interesting and simple one. See here the equivalent inductance between P and Q. So inductance between P and Q, what they are equivalent inductance. First one, see a current will be created. See in between P and Q, if you are maintaining an voltage, a current will be created by the production of voltages as a result of shifting of, see a shifting of magnetic field from this one and this one. In this case, the equivalent inductance and equivalent resistance. See here in case of resistance we used to mention in case of Ohm's law with the help of similar like this one you can mention like this is a resistor, and this one also a resistor here. These two inductance are connected in parallel, and this parallel combination is connected in series with the third one. See that one I just mentioned here, this is L1 and this is L2 and this is L3 here. Now L1 and L2, simply I just mentioned here, L1 and L2 are connected in parallel. So these parallel connections are connected in series. So series with the L3 here. Now according to this one, so parallel connection I just mentioned here, 1 by LP is equal to 1 by L1 plus 1 by L2 here. See from this one, 1 by LP I just mentioned here, 1 by 2 plus 1 by 4. Simple one. This is half, this is half, this is quarter. Half plus quarter here is 3 quarter, or you can mention here 4. This is 2 times and this is 1 time. So what you are having here is 3 by 4. Right. Now from here LP here is 4 by 3. Now this one LP plus L3 that are connected in series. Now you just mentioned here LP here is 4 by 3 and this one here is they have given 2 by 3. See from this one 3 if you take 4 plus 2, so what you are having here is 6 by 3, that we call it as 2 Henry. So the resultant inductance across P and Q here is 2 Henry. The answer is this one. The next problem is about a mutual induction. If a change in current, they have given change in current here is 0.01 ampere in one coil produces a change in magnetic flux, they have given 2 into 10 power minus 2 Weber in another coil. So the mutual induction of two coils in Henry. First one, what do you mean by mutual induction? Now you just consider a two coil here. See there are two coils. This one, there are two coils over here. See the mutual induction is the process. See I just mentioned here mutual induction is the process of generating EMF, electromotive force, in one coil due to changing current in the secondary coil which is placed nearby to the primary coil. Both are physically insulated but magnetically not insulated. See, it occurs when two coils are placed together. That mutual induction can be happen when the magnetic field of influence can be present on either side of the coil. See, in that case, I will mention here when a current passing through one coil, that will produce a changing flux on the coil. See, I just mentioned here this changing flux is linked to the secondary coil here. This changing flux is produces current in the secondary coil. Now this coil has been connected to the galvanometer here, and this coil which has been connected to a potential, right? So that what happened here is, see both are not connected to each other, physically not connected to each other, but even the galvanometer shows a deflection. See for the first one, see induced EMF is directly proportional to rate of change of flux. In the second cases, induced EMF is directly proportional to, I just mentioned here, directly proportional to changing current. See from this one, E is equal to M into di by dt, where M is called as mutual induction. From these two equations, from first equation, from this second equation, see what we are going to find out here is both the case d pi by dt, that one will be equal to m into di divided by dt here. So what they are asking in this case, they are asking about mutual inductance. So m is equal to d pi by dt whole divided by di by dt. Now they have given about a changing flux here is 2 into 10 power minus 2, and this one changing current here is 0.01. So this one 0.01 is nothing but 10 power minus 2 here, so both will be cancelled here. So what you are having here is mutual induction is 2 Henry. So answer in this case. Again mutual induction. See first you just know about a formula here in case of mutual induction. So what are the data they have given? First see here changing current 5 to 10 ampere, and time here is 10 power minus 2 second, and EMF they have given 15 millivolt. So what they are asking here is mutual inductance. See here, hope you know about this formula. See changing current, that is di by dt they have given, but induced EMF in the coil is directly proportional to di by dt here. See from this one E is equal to m into di by dt. This is about mutual inductions here. See what they are asking, mutual induction. See E value they are given. E value here is, see this one 50 millivolt, time changing time they have given, and even a changing current we are going to find out here. E value here is 50 into millivolt means 10 power minus 3 volt, and m into that one we are going to find out. Di changing current here is final minus initial here. Final is 10 ampere to initial 5 ampere, and time here is 10 power minus 2. See from this one, m is equal to 50 into 10 power minus 3 is there, and this one 10 power minus 2, and whole divided by 10 minus 5 here is 5 ampere. You just cancel it for 10 times. Say from this one, m is equal to 10 into, see, all the answers are in microampere, so 10 into 10 power minus 5, not ampere, this is Henry. Mutual induction means Henry. Or even you can mention here 100 into 10 power minus 6 Henry here, or even you can mention this one, that is 100 micro Henry. So answer in this case. To the next problem, this is a old question paper problem here. See, two coaxial solenoid are made by winding thin insulated wire. See, that one I just mentioned. One solenoid, it will be appears like this. So solenoid means number of turns per unit length. So and another one more solenoid, both are arranged coaxially. See, another one I just mentioned like this one. See here, another one which is in a blue color, both are coaxially arranged here, and both are physically touched together but electrically insulated. See, which has been connected with a thin insulated wire over a pipe. So that what happened here is, this is physically touched together but electrically insulated with the area they have given, and the length here is 20. This is not pipe, this is only 20 centimeter. There is a mistake here. And if one of the solenoid is having 300 turns, another one is 400 turns. See, this one you can mention here. See, number of turns per unit length you can mention like n equal to capital N divided by L. Similar in this case, N1 equal to N1 divided by L, and so unit length. So length has been constant here. N2 equal to capital N2 divided by L. See, in all the cases I have mentioned important questions in this box, in the glittering box, you can understand here. And next one, mutual induction they are asking here. Mutual inductions, you can mention this one. See here, two solenoid which are connected here is, which are connected together. The mutual induction between the two solenoid, m equal to mu naught n1 and 2. Pi r square here is area into L. If it has been filled with some other material, so what you are going to have here is relative permeability, means mu r should come in addition. So in that case, mutual induction, what I am going to mention here is m is equal to, see, I just mentioned here, m is equal to mu naught n1 n2, area here is A and L. Now from this one, say from this one you can substitute all the values here. Mu naught into n1 here is capital N1 divided by L, and capital N2 divided by L, and area you can mention like A into L. Now you just cancel this one. See, from this one the final formula what we got here is mu naught N1 N2 A divided by L. Now substitute the values here. Mu naught value here is 4 pi into 10 power minus 7. N1 here is 300 turns, and N2 here is 400 turns, and area what they have given here is 10 centimeter square. 10 into centimeter we have to convert this one meter, that is 10 power minus 2. 10 power minus 2 whole square here is 10 power minus 4, and whole divided by what they have given, the length here is 20 centimeter, so that is 20 into 10 power minus 2 in meter. Now you just cancel here, one cipher will be cancelled. This is for 2, so 2 pi is there, so 2 pi, so this one you just cancel this one. 10 power minus 2 here is 10 power minus 2 will be there, so 2 pi into 10 power minus 7 into 4 into 3 is 12, 4 cipher is there, and into this one additional what you are having here is 10 power minus 2. Now you just cancel this one. In that case, 12 into 2 here is 24, so 24 pi. This 4 cipher will be cancelled in this case, that is 10 power minus 3 is there, and this one 10 power minus 2 is there. So what you are having here is 24 pi into 10 power minus 5. But what they have given, this is in Henry mutual induction, but in all the cases they have given in 10 power minus 4. 10 power minus 4 means 2.4 into pi into 10 power minus 4 Henry. So answer in this case, yeah, additional one of the fortunate thing, they have given the hint 10 power minus 4. So whether this one or this one only the answer, these two will not be there. So that is one of the things that we can So this is easy. This is about the mutual induction. See, always remember the formula. An EMF induced in the secondary coil. So EMF they are given, that is 20,000 volt. When a current breaks in the primary, the mutual inductions they are given, that is 5 Henry. M value they have given. The current reaches to 0. So from some values to 0 within 10 power minus 4 second in the primary. Calculate the maximum current in the primary before it breaks. So what's the current it was before it breaks? So that one, according to this formula, you just remember here. What is the mutual induction formula here is EMF E is equal to, that is M into di by dt. Now this one E value they have given, that is 20,000 here, 20,000 into mutual inductions they have given. Mutual induction here is 5 Henry, and current one here is I final is a high minus 0 here, or even you just mention as high, and the timing here is 10 power minus 4. See, from this one what we are going to find out here is I is equal to, see this one, 2 into 10 power 4 is equal to 5I divided by 10 power minus 4. See, from this one, see 5I I just mentioned here, 5I is equal to 2 into 10 power 4 into 10 power minus 4. These two will be cancelled here, so I is equal to 2 divided by 5. That one will be equal to 2 by 5, that is 0.4 ampere. So answer in this case, the end of the session. Before winding up the sessions, let me introduce about the concepts on next presentation is about mutual inductions alone. See here, on old question papers on mutual inductions only will be discussed on the next presentation. And I thank you all for your patient listening and gone through this presentation on self and mutual inductions here. Really, I truly appreciate your time and interest. I hope the concepts are now little clear. If you found the session is very helpful and engaging, please put put like and comments and subscribe the channel for more educational content. If you enjoy this video, right, then we'll see this next on mutual induction. Till that, you just stay curious and keep learning on physics. We'll see in the next session. Thank you.